Good morning, students. Myself Kausik Chakraborty. Today's our topic is counter. At first, we want to know what is counter. A digital circuit which is used for a counting pulse is known counter. Counter is a application of flip-flop. It is a group of flip-flop with a clock signal applied. Counter are two types. Number one, asynchronous counter. Number two, synchronous counter. First is asynchronous counter. Asynchronous counters are those whose output is free from the clock signal because the flip-flop in asynchronous counter are supplied with different clock signal. They may be delay in producing output. The required number of logic gates to design asynchronous counter is very less, so they are simple in design. This is the example of 2-bit asynchronous counter. Here we use two JK flip-flop. Q0, Q1 is the output. This 2 high is the input. The main point in asynchronous counter is different clock signal. Look at the picture. In first JK flip-flop, we use one clock pulse, and the second JK flip-flop we use the another clock pulse. Next is synchronous counter. In synchronous counter, the clock input across all the flip-flop use the same source and create the same clock signal at the same time. So a counter which is using the same clock signal from the same source and at the same time is called synchronous counter. This is the example of 2-bit synchronous counter. Here we use two JK flip-flop. Q0, Q1 is the output. Logic high is the input. The main point in asynchronous counter is same clock pulse. Here we use the same clock pulse in same time. This is the difference between asynchronous counter and synchronous counter. First point, asynchronous counter. In this type of counter, flip-flop connected in such way that the output of the first flip-flop drives the clock for the second flip-flop. The output of second, the clock of the third, and so on. First point, synchronous counter. In this type of counter, there is no connection between the output of first flip-flop and the clock input of the next flip-flop, and so on. Second point, asynchronous counter. All the flip-flop are not clocked simultaneously. Second point, synchronous counter. All the flip-flop are clocked simultaneously. Third point, asynchronous. Design and implementation is very simple even for more number of states. Third point, synchronous. Design and implementation became complex as the number of states increase. Fourth point, asynchronous. Main drawback of this counter is there are low speed as the clock propagate through a number of flip-flops before it reach the last flip-flop. 4 point, synchronous counter. Since clock is applied to all the flip-flop simultaneously, the total propagation delay is equal to the propagation delay of only one flip-flop. Hence, there is faster. Next is ring counter. A ring counter is a type of counter composed of flip-flop connected into the shift register with the output of last flip-flop fed to the input of first and making a circle or ring structure. Look at the picture. This is the circuit diagram of 4-bit ring counter. Here we use the 4D flip-flop. 1, 2, 3, 4. This 4D flip-flop is connected each other. And we also use the 4 negative clock pulse. This 4 negative clock pulse is also connected each other. This is clear terminal and this is preset terminal. The main point or the main connection in this circuit is the last flip-flop output means Q0 is connected to the first flip-flop input means Xi. So look at the truth table. Clock pulse Xi, Q3, Q2, Q1 and Q0. Initially, when the clock pulse is 0, this time Q3 value is 1, Q2 value is 0, Q1 value is 0 and Q0 value is 0. Q0 value 0 means Xi value also 0. When the first clock is applied, this time Xi value come to the Q3, Q3 value come to the Q2, Q2 value come to the Q1 and Q1 value come to the Q0. That means this time Q3 value is 0, Q2 value is 1, Q1 value is 0, Q0 value is 0. Q0 value 0 means Xi value is also 0. Similarly, clock 2, clock 3 or clock 4 is same. In clock 4, Q3 value is 1, Q2 value is 0, Q1 value is 0 and Q0 value is also 0. This state is similar to the first state. That means it creates a circular structure or ring structure. So that's why it is called ring counter. This is the timing diagram of the ring counter. At first we look the truth table. When the clock pulse is 0, this time Xi value is 0. When the clock pulse is 1, this time Xi value 0. When the clock pulse is 2, this time also the Xi value is 0. When the clock pulse value 3, Xi value 1. When the clock pulse value is 4, Xi value 0. So go to the timing diagram. This is the clock pulse. This is 0, this is 1, this is 2, this is 3 and this is 4. Xi value. Initially clock pulse 0. This time Xi value is 0. Clock pulse 1, Xi value 0. Clock pulse 2, Xi value 0. Clock pulse 3, Xi value 1. Clock pulse 4, Xi value 0. Similarly, Q3, clock pulse 0, Q3 1, clock pulse 1, Q3 0, clock pulse 2, Q3 0, clock pulse 4, Q3 0, clock pulse 3, Q3 0, clock pulse 4, Q3 1. So when the clock pulse 0, Q3 1, clock pulse 1, Q3 0, clock pulse 2, Q3 0, clock pulse 3, Q3 0, clock pulse 4, Q3 1. Similarly, Q2, Q1, Q0 in same process. Thank you. Next class we discuss about the different type of asynchronous counter and synchronous counter.